Sarah, what do you think? Should I kick it off now?
Let's do it. Let's go for it.
Okay, well, first of all, I just want to say a warm welcome to everyone, and I hope that the next couple of days are packed with interesting opportunities to learn about what's happened and what is going to happen. So we have a pretty full schedule, so I won't dawdle here. So next slide, please. So Julie, I'm not seeing the next slide flip. Is it just me?
I'm not
I
either.
think Julie's not hearing me. That's the problem.
Julie, I
Julie,
believe
can you hear me now?
Julie was having some internet issues, so I will share my slides.
Okay,
All right.
sounds like a good. So, Patrick, do you want to kick off this section?
Sure. And can you hear me all right? I'm testing out a new microphone so it doesn't explode. All right, perfect. So yes, welcome everyone. First, we've got our virtual meeting roles. So you can see we have the maestro who will be a mute master, raised hand monitor, and general security to make sure that we don't have anyone intruding on the Zoom who's not invited. And that will be Amanda Miller. And you can see her Slack on the far right. Screen sharing hopefully will be Julie once her internet issues are resolved, or someone else at Rincy. Slide content, person who will be updating the slide content will be Sarah. The moderators will be Becky and Stan, and you can see their Slack handles as well at the right. Note takers and Q&A monitors, you see we have a full team. Myself, Patrick Patton, Paul Kerr, Ali Gartland-Gray, Joe Sayre, Tom Madden, and John Cheadle. We will all be serving in that role, and you can see our Slack handles as well. And then Time Watcher, who will keep us on track, is going to be Sarah Davis. Next slide. All right, and so questions, if you have questions during the event, we will have dedicated slots for verbal questions. We do ask that if you have a question that you use the Zoom raise your hand feature. So if you are not aware of how to do that, you should be able to go to participants and there'll be a raise hand button there. Or if you go to reactions, there will be a raised hand as well. The Zoom chat, if you click on the chat button, you can see we'll have a chat window running throughout this meeting. As mentioned, we'll have a team of PMs monitoring that to make sure everyone's questions get addressed. You can also, if you go to the Slack workspace for NCPI, you should have received an invitation to the October workshop channel. We encourage people to have any conversations in the next couple of days in that channel. If you have not received an invitation to that channel because it is a private channel, please email Amanda Miller, and you can see her email is there, and we'll put it in chat as well so everyone has access to it. And next slide. And we will have a series of breakout sessions, and in the most recent versions of Zoom, you have the ability to move between different breakouts. So we do encourage you, if you have not already downloaded the most recent version, please do so. Not right now, but during a break, and then rejoin. And so you can see if you are in the slide deck, we've got instructions linked and a how-to video on how to download the most recent version. And then, as you may know, we are trying to have an accurate head count and a list of everyone who has attended. So if you have not yet registered, but you have this link, we do ask that you register via the form that is linked here, or you can see we've got a bit.ly/NCPI 2021_register. So please do register. We will be following up with people who have not registered but are in the Zoom. So go ahead and do it proactively so we don't have to bother you. So next slide. All right, Stan, I will hand it back over to you.
So thank you very much, Patrick. I just wanted to emphasize that we do have a statement of conduct, and we are very meticulous about reading this each time because we want to make sure that we're adhering to these principles. The Biodata Catalyst Consortium, and in this case we'll say the NCPI meeting, is dedicated to providing a harassment-free experience for everyone, regardless of gender, gender identity and expression, age, sexual orientation, disability, physical appearance, body size, race, or religion, or lack thereof. We do not tolerate harassment of community members in any form. Sexual language and imagery is generally not appropriate for any venue, including meetings, presentations, or discussions. Next page, please. Next slide. And we also try to operate by what we have now come to call the Santa Cruz Rules of Engagement. Do not be shy from identifying problems and risks. And in this particular meeting today, we absolutely do, today and tomorrow, have a few places where we have problems and risk, and we need to be candid. We all need to be heard politely. So if you can't be heard in your native voice, if you will, identify an ally or somebody that you can help to get motivated, help to get you into the conversation via Slack. You can reach out to a contact for a particular topic. In general, you can send email to our Slack to bdc3@renci.org if you don't know the contact. And please be polite. I'm a talker, and I have to remember and remind myself to give others time and space to talk. And if you're quiet, please do take advantage of openings to be able to express yourself. And any comments and ideas, you can always add those to the notes if you don't find a space to talk, and we'll talk about the notes and where everything is located here shortly. Next slide, please. So with that, it's my great pleasure to welcome Susan Gregurick. Susan is the, well, I'll let her introduce herself because I'm not exactly sure that I have her most current title, but she is in the Office of Data Science and Strategy, and I'm very glad that we will be able to hear from her and where her office is tending toward in the near future, because that will definitely have an effect on all of us, and all of us have been beneficiaries of the strategy and plans and actions that have been taking place in Susan's office. Susan, I'll turn it over to you.
Thank you so much, Stan. It's a real pleasure to be here today. My talk is really more meant to be an opening conversation and not sort of a dissemination of information, although there's certainly going to be a lot of that. But what I hope is that what I do is to provide a forum to begin this conversation of what really does a data ecosystem look like from your perspective, as well as from our perspective at NIH. Just let me know, am I sharing my slides, Stan, or are you sharing my slides? I don't remember who has the ball.
Susan, I believe we just have if you could share your slides, please.
Okay, will do. And also, let me know when I have talked too much and you need me to stop so that we can move the meeting forward, because I think I have jam-packed with a number of slides. And again, the slides can be made available to everybody. Okay, now another reality check. Sometimes the screen is cut off, but does this look good to you?
It looks great.
Okay,
Perfect.
fantastic. And again, just stop me. I can't see the chat, so you're going to have to break me off and tell me it's time to end, and I'll go to the last slide. So I just want to present some compelling use cases that you are completely familiar with. I think a lot, and many of us at NIH think a lot about our investigators, our single investigators sitting in the lab, and they're generating a lot of data, and pretty soon they're going to have to submit a data management and sharing plan to go with their R01 or their U24 or many of their other types of mechanisms that they would like to receive funding for. And where do they start and what do they do? This is a compelling use case that certainly keeps many of us up at night. Here's my use case that I got from you. And this is just one of the very many important use cases certainly studying rare diseases like pediatric cancer are completely challenging because it's incredibly difficult to find data about any single participant across many systems. I've heard this many times. And there's also, just tracking participants in clinical studies through the course of their health trajectory and all the ways that they interact with our healthcare system is incredibly challenging. And anything we can do to really increase the value of their contribution to data science and to research is critically important. And finally, we've been launching a number of AI programs, and certainly it's always interesting to see the intersection between data science and AI and computer science. And there's a lot of really great efforts that I won't get to today that NIH is starting to launch, Bridge to AI, Aim Ahead, and other AI efforts that certainly can be brought to bear. Let me just talk a little bit about the data management and sharing policy and how we can start to think about that from a data science perspective. This is the policy. It will go into effect. This is kind of a shorthand of the policy, into effect January 25th of 2023. So we don't have a lot of time to get everything ready. It will require NIH investigators, all NIH investigators, including intramural investigators, to prospectively plan for how scientific data will be preserved and shared. You'll be submitting a data management and sharing plan. Your plan should outline how the scientific data that you're generating and any accompanying metadata will be managed and shared, including any potential limitations or restrictions on the sharing of that data. This plan is going to be part of your budget justifications in the extramural award community and part of the technical evaluations for contracts. There's a different way that we'll handle it for intramural researchers. So we're all going to be getting ready for this. On our side, the review of the data management sharing plan, and on your side, the submission of it. Just a note that this includes funded research conducted by extramural grants, contracts, and intramural researchers, as I have said, but it does not apply to grants or activities that do not generate scientific data, including our training grants, our infrastructure grants, and our non-research activities. So for the most part, this is going to impact a very large number of investigators. How can we get ready for this? We have to consider it both from the data side. How do we make the data more fair, more AI ready, more reusable, and how do we actually get the repositories ready for this so that we have an ecosystem that supports data from generation to reuse? So I just want to call out the work that a number of my colleagues did in the BMIC consortium to develop and then work with OSTP to finalize the desired characteristics for all data repositories. You see these desired characteristics that align with the FHIR principles here. We certainly want to enable our data repositories to begin to instantiate these FHIR characteristics in a meaningful way. But we also want to, of course, support FHIR data, and many thanks to Ingrid Dillow for this slide, and trust. Trust in repositories is sort of the analogous FAIR data principles, making sure that the repositories are transparent about their services and their holdings, that they're responsible for the authentication and integrity of the data within their holdings, that they do focus on users and use case, that they are sustainable, and this is always an interesting discussion, and finally, that they have the technology and capabilities to support secure, persistent, reliable services. And many thanks to my colleague Dawei Lin, who led a group to develop these trust principles. So what can we do at NIH to support data repositories that align with the desired characteristics that support FAIR data sharing, and trust principles? This won't come as a surprise to you, but NIH supports a large number of data repositories and knowledge bases. And they come in many different sizes and different forms of complexities, and actually different levels of maturity. Some are just starting out, and in fact, many of these tend to be funded through the R01 or similar mechanisms, and others are very mature and have been instantiated for long periods of time. The one from my community is the Protein Data Bank. That's probably at least as old as my scientific career, maybe a little older. So, we have to think about the fact that we don't have necessarily a one-size-all program when we think about data repositories. Each of these repositories brings value to any given research area. But we do have to consider that they are in different stages of maturity and they need different funding activities. So we want to be able to address the spectrum and readiness of these repositories. And we also want to help the community work together to develop metrics for their usability, their utility, and their impact. And I've been involved in a number of workshops that have talked about how do we actually develop metrics for data reuse through repositories or through other mechanisms. And I think this is an ongoing conversation, but at least we want to have more than just workshops in this area. So what we did is we supported this year a NOSI for supplemental funding to support existing data repositories to align with the FAIR and trust principles and to help them become more adherent to the desired characteristics. So here we go, we did the trust and FAIR principles, and we supported 14 awards this year, including 5 to intramural research repositories. You can see the number of institutes and centers that are working with ODSS in this area. This is just a start, and I believe that you will see in the next couple of years, or certainly in the next few months, more activities in positioning repositories. These are all community-driven repositories, but also generalist repositories, to begin to really think about how we're going to support that data management and sharing policy as it moves into its implementation phase in 2023. But thinking about repositories is just one side of the coin. The other side of the coin is thinking about the data that's generated in the lab, and we'd really want to capture that FAIR data principle at the generation of the data and not too far downstream. The further we leave the bench, the more harder it is to make data more fair and more AI ready. And it's challenging. It's not simply formulaic. It requires engagement with researchers and feedback. And it's often driven by use cases, as many of the activities that you do are driven by use cases. This includes aspects of data science and data information, such as the presence of noise in the data, the specificity or uncertainty of the labels of the data, the amount of data, the data paucity, and the challenges in preparing AI and FAIR data, including also, and this is standard activities such as the documentation, the provenance, and the attention, and this is the hardest one, the attention to bias that may be sort of implicit or explicit, that really complicate using data in AI and other algorithms. So one of the things that we did this past year, and this is really going a little outside of the recommendations of the ACD AI working group, is to support collaborations to improve the AI, ML, and FAIR readiness of existing data. So this is collaborations to bring in experts in biomedicine and data management, artificial intelligence, machine learning, and biomedical sciences. And we supported a number of awards, and you can see here the breakdown of the awards. These were all in the extramural community. And interesting, the science focus of these awards, focusing on Alzheimer's, cardiovascular, and aging. And then the types of data that people were most interested in improving their AI readiness and FAIR readiness. I'm really happy that we're able to partner with a number of ICs. I think that we're going to think about this for the following year, and I'd love to see more ICs participating in the concept and the conversation of how do we, take the data that we have and make it more fair and more AI ready. I think throwing away good data is not necessarily always the right solution, but I understand that it is a solution. So I love the concept that if data is oil, then software is the refinery. And so working in data science means that we also work in software and software science, I guess. So we have been running for a number of years, enhancing software tools for open science, bringing in new collaborations between biomedical researchers and software engineers, and working closely with our STRIDES initiative. And I hope in the future you'll hear even more activities in STRIDES that will impact directly NCPI. One of the things that we've been doing is a NOSI to enhance and improve the effectiveness of NIH-developed software for open science by bringing in those collaborators. But I'm also going to tell you about something that we've done just within NIH and our BISTE consortium, which is to develop best practices for open software development and sharing. And I'm going to share those with you in just a minute. But every year we've been running a NOSI to help NIH-funded grantees who are developing software, make that software more cloud-ready and improve the amount of user and usability of their software. And you can see the number of awards for FY20 that have now generated over 120 scientific publications. I'm thrilled to say that. And I love this one from the University of North Texas that actually advanced biomedical modeling software. I think that's a functional theory software to become more cloud ready through Azure, as well as community outreach through this graphic novel for the Latinx Chem community. It's really kind of a cool award. And just a note, the topics that were funded in FY20 include FHIR clinical research, mapping clinical research to the FHIR resource, Cloud Commons, not uncommon here, and then others such as large-scale biomolecular dynamic simulations, new biophysics for force field development, and even new neuroimaging applications. So I think enhancing software is great, but developing best practices for software, and these are truly best practices, will enhance a large number of researchers in the software field, providing transparency, serving the key goals of rigor and reproducibility, enabling reusability of software, and continuing that conversation with software communities. For us, helping us track the investments of the funded software that we are engaged with, and creating software and code that can be inclusive of metadata and citations, and finally aligning with the NIH strategic plan for data science. I'm putting the link here of where the software best practices are. It provides information on how to make software more open and more citable. It allows for researchers who are developing research-ready software to be now transported into medical practice or clinical settings. We talk about software vulnerabilities. There's a good section on metadata. You may see a request for information in the near future, particularly focused on the metadata components of these best practices, and then ideas on benchmarking and provenance. Oops. So I hope that you'll take a look at those best practices for software. This is, again, not a policy. It's just an FAQ on ideas for developing best practices for software. It's developed through all of the work that's happening in the journals and the journal community, as well as other societies. So let me just spend the last few minutes, and I hope I'm not running too far over, to talk about where we are today. You would know that we've been doing a lot of work with our researcher auth services. We've worked with a number of institutes and centers that are now integrating data access through RAS. A number of ICs will onboard in the next 1 to 2 years. It's actually becoming a fairly large program. We're working with other consortium outside of NIH for integrated plans for greater data access. As you know, we're leveraging community standards such as GA4GH. We're also aligning with the administration's cybersecurity goals on multi-factor authentication, coming soon to a resource near you. And so having that aligned in RAS is really important. So right now we're working with the Commons Federation. As of September 16th, not too long ago, researchers from any organization can now log on to ERA using multi-factor authentication and their university credentials. So that's a really big plus for many researchers. RAS is going to be adopting this capability. And so I think that having researchers not have to just use their ERA Commons or login.gov accounts is probably going to be a big plus for everybody. You're here. I'm so thrilled to be here with you. And here's where we were last year. This is just a reminder of all the great work that you've done and that you're continuing to do. But there are other ecosystems or other activities, and I know that the Common Fund Data Ecosystem is here, so thank you very much for these slides. You probably know this, but just in case it's a refresher of all the good work that they're doing to enable users to query across their Common Fund data sets, sustain their data and their tools and train new users to work with Common Fund data. And it's a large number of Common Fund data coordinating centers that are slowly integrating into the Common Fund data ecosystem. And we're working closely with them. I'm glad that they're here. You see a picture here of all of the DCCs that are integrating into the Common Fund data ecosystem. They have currently now engaged 10 of the ecosystems, and they're circled here. And they'll be now implementing DERS in the coming year, supported by my office, and I'm happy to support the integration of Common Fund data ecosystem into the larger effort. There's other efforts. There's MIDRIC. It's interoperability across different repositories and scale, integrating both clinical, EHR, pathology, and omics data to be mutually beneficial, to think about scales and multi-omics data. So we're doing a number of pilot projects between the Imaging MIDRIC Resource Center, the National COVID Cohort Collaborative, N3C, and the Biodata Catalyst Pedal. There's a lot of really interesting work going on in records linkage through PPRL that you may hear about in the future. I'm just going to show this. I'm not going to talk through it, but this is here for your consideration. These are the pilot projects underway between MIDRIC and N3C, and MIDRIC and Biodata Catalyst. And I hope that at least some of you are involved in some of these activities. But one thing that I will note, that a lot of what you're seeing in the dashed lines about security, compliance, and boundary for systems is super important, not just for NCPI, but also for Recover in other areas where we have a number of great data resources, Biodata Catalyst, all of us, other platforms like N3C. And we need to develop a way to integrate workspaces and notebooks in a FSMA moderate boundary that will allow us to work together and yet still maintain the authority of each repository. Included also in this conversation is HEAL, building the Helping End Addiction Long-Term community, allowing for greater data management and data sharing, and broader research engagement. So HEAL is providing a sandbox. You're going to hear a little bit more eventually about sandboxes and cloud labs to provide user-friendly search and interface environments in a secure cloud computing environment to provide analytical tools and diverse representation of data sets. Here's a little bit, and thanks so much for the RENC and the UChicago team for the slides, where you can see some of the work that they're doing and some of the upcoming recommendations, including fair assessment of metadata and importance and intro into ontologies and controlled vocabularies, most likely also venturing into the world of common data elements. We've been doing a lot of work at NIH in common data elements, particularly in the RADX program, and harmonizing data across many different RADX projects, everything from a digital health platform to a consortium RADX up of underserved populations. And some of the missions and visions of other efforts, such as the NIAID data ecosystem, to create a federated data ecosystem to provide secure environment for users to, again, find, access, query, and analyze. These are all very, very common themes. Both a portal developed by Scripps as well as an analysis workbench provided by Seven Bridges. And finally, last but not least, the efforts of BRICS, the bioinformatics computing system. And you'll see here all of the activities that BRICS is doing to support their ecosystem. And you'll see the number of different programs that all use BRICS. And so one of the conversations we've been having at NIH is we have all of these different instances of BRICS. How do we actually create a more unified and consistent BRICS system that can share data and tools across all of these different BRICS instances? And so this is a conversation that we'll be having over the next year or so. So there's a lot of different ways that NIH is instantiating and thinking about data ecosystems and data interoperability and platform interoperability. And so my point here totally is only to get a conversation started about what you think it might look like. And these are just a straw man argument for you to consider, and how we move forward, and the input that you give us will be very impactful for what we do in the future. I hope that you'll think about, what does it really mean to handle data both in the FAIR as well as in the CARE principles? How do we actually enable repositories to easily share data across repository systems making meaningful metadata both within and across systems so that we can actually find data in a way that's facile. How do we instantiate software engineering best practices and principles and enhance an open community? And I love what GitHub is doing to really make software much more findable and accessible. How do we enable a cloud analytics platform that can cross boundaries, both security and otherwise, to enable greater research usability? Important in all of these, of course, is training new colleagues to really be very adept at biomedical, data science, information and computer science domains. And finally, partnerships that may cross international boundaries, perhaps with the UK or the EU, or perhaps with other international partners. And always on everybody's mind is sustainability of infrastructure. And that is the end. I think, yes, that is the end. I just want to thank you very much for allowing me to come. I hope that I have allowed at least a little time for a discussion. And thanks, Dan. I'm going to stop sharing and turn it over to you.
So, Susan, thank you so much for such a comprehensive and stimulating slide deck. And I could see Valentina has her hand up, and there was also at least one question I caught in the chat. And so we want to use this opportunity in Susan's time to ask her questions or engender a dialogue on topics that we think depth are needed on. So Valentina, let you go first.
Yeah, Susan, this was great. Thank you. I have a question about one of this interoperability pilots that you're running. It includes Biodata Catalyst, All of Us, and others, biomedical imaging, something. I'm sorry, I don't remember the acronym. So can you say a little bit more, and maybe Biodata Catalyst can do that too, about what APIs are being pursued? I hope they are in line with what we're doing at NCPI. But yeah, I'd like to learn more about what solutions are being tested in that particular project.
Absolutely, and I may need to actually phone a friend in BDC. But here, MIDRIC is a consortium funded by NIBIB to enhance medical imaging across a number of societies that deal with radiological societies that deal with a large amount of imaging data. So they store images, they store the metadata for those images and annotations. And so I think what we're seeing here in this collaboration is to provide an integrated support for not only the imaging tools, but also the imaging tools with respect to the clinical study and all of us tools. A lot of this is, I think, pretty early in its days, but what they want to do is they want to have the ability to deliver these images to different cloud-based systems such as N3C and Biodata Catalyst and others. And that integrated vision requires an awful lot of work in not only creating a system that allows sharing of data on an analytics platform, but also linking the data across these platforms to the people that contributed the data. I'm going to just see if maybe people from BDC or even UChicago, who are leading the infrastructure on MIDRIC, want to say a little bit more about some of the work that's going on.
Bob, do you want to take this, or is there somebody more appropriate that I'm not aware of? I have not been involved in this discussion in any meaningful fashion. Or John?
I won't speak to about. I'll let someone from Biodata Catalyst answer for Biodata Catalyst. I think Susan explained it extremely well. The only thing I would add is the MIDRIC includes RSNA and ACR, the two largest radiological associations, and includes their best practices for processing data. And then MIDRIC is committed to making the data fair, creating a repository of trust, and interoperating with workspaces that are authorized by the respective commons, so that there could be interoperability across the ecosystem, as Susan described. But I'll turn it over to others to talk in more detail.
John, you want to share?
Yeah, sure. My apologies for coming late. I had to be on a pediatric COVID meeting with IC directors. So the pilot, I believe that Susan was talking about, and I didn't see the slide that was shown. We are doing a pilot of actually COVID images. So NHLBI has funded a number of observational studies within one of our networks that focuses on ICU patients. And so they've collected a number of images, chest CTs, echocardiograms, chest x-rays, and the clinical data will be deposited within Biodata Catalyst. We have some of that data already and are just waiting on a publication. Others will be coming in shortly. That network has been working with ACR to store their images, and so Midrick will be ingesting them through their pipeline, and then we'll be working with Bob and his group at Gen3 to co-localize the image data with the clinical data in Biodata Catalyst workspaces. So that is the funded pilot so far.
Thank you.
Ben, do you want to ask the question that you posed earlier in chat, which I think Susan spoke to directly, so it's a perfect setup.
Sure, I'd be glad to. Susan, I really appreciated your emphasis on software best practices and development. And I'm curious to hear more about training efforts and whether you view, do all life sciences graduate students need to become bioinformaticians and programmers, or what are the training efforts to make these cloud-based development best practices what people do and how they learn from the beginning of their scientific careers?
Thanks, Ben. That's such a great question. And there's so many different ways that we can tackle training, that we have work that we're doing to bring undergraduates and actually senior level people to NIH to work on challenges through our Data Scholars Program, which maybe some of you may be interested in, or if you have really talented undergrads, to send them here for a 10-week summer internship to work within the programs, mostly in AI-ready fields. But we're also doing a lot of work in the extramural community. And some of this is sort of hidden behind the scenes. We've been partnering more with NIMHD to do a lot of basically hands-on training at HBCUs. We started with the pilot with Howard. We're now expanding to all HBCUs and also all Hispanic serving institutions to begin sort of curricula and hands-on training developments. We're also going to be funding a training coordinating center within the TAC, the tribal epicenters. So you're going to get a theme here to help develop curricula and training capabilities within tribal communities. That's actually one of my goals for 2022. You might hear a little bit more about a tribal data repository that will also have training capabilities. In addition, we've been working with Strides to set up what we're calling Cloud Lab. And this will enable researchers of any level and idea in underrepresented institutions to basically have a sandbox with pre-configured tools and pre-configured data to start experimenting with moving their software to the cloud. Not every institution, it's not a surprise to you guys, that is really ready for the cloud or even ready to think about the cloud. So we are providing a safe environment where they can experiment at no cost to them, tools and capabilities in the cloud. I think you may also hear in the near future about an instance of Cloud Lab, which will be more practical for NCPI, that allows researchers to sort of benchmark and cost project their high throughput workflows in the cloud on any cloud system. I'd love to see more capabilities in training and Kubernetes and cross-cloud compute, but there may be other solutions as well. developing, sort of those T32 training capabilities. We are starting to partner with institutes, and IGMS is a big holder of the T32 training to support T32 data science training activities. So what we try to do, you'll get the theme, is partner with ICs, meet people where they are and where they need to be trained, and then move forward. The only activities that are truly ODSS solely funded is Cloud Lab through Strides. And the data scholars and the data interns that come from undergrads. But most of the other training activities are strong partnerships with the ICs. I forgot to mention, I have a new partnership with NHGRI to do diversity training of data science in diverse communities. While it is focused on genomics, it's not exclusively meant to be genomics. So I hope that answers your question and you get a sense of where we're going in our training capabilities.
It does indeed.
Thanks,
Thank you very
Susan.
much.
Thanks, Ben. I can't emphasize too much how much the training issue is looming. We have to start figuring out how to deliver to where people are, exactly as you said, Susan, and including the diversity and lowering the bar that is being discussed in the chat.
Yeah, and
we have time. Go ahead.
Sorry, Sam, I'd just love to know, like, what can we do with NCPI to lower the bar for the communities that you serve? That would be a great conversation to have at some point in our 2 days.
Great. So we have time for one more question. I'm waiting 7 seconds, which is our rule. Okay, so the 7 seconds are over, but I'm going to ask a question. So Susan, this is very self-serving in an odd way, but is there going to be, and Valentina's going to yell at me, I think, is there going to be an ongoing effort to continue to have discussions around policy issues? I know you have some groups that are meeting internally, but this has proven to be a sticky wicket, as Bob and others will report out in the next couple of days.
We've been having a number of groups meeting on different aspects of policy, from the policy and capabilities of the many different types of people involved in NCPI, including the developers, and how we can enable, more facile developer access to policies that have to do with cybersecurity and how you actually create something that looks like a free port or a multi-cloud, multi-platform secure boundary. And as you can imagine, policy moves kind of at the glacier speed. It tends to, because it's a policy, it has to go incredibly thoroughly deep, and therefore it moves slow. And sometimes that's why you almost never see anything until the very end. So we are absolutely thinking about the different types of policies that are going to be needed to enhance and enable NCPI to be truly effective. Hearing from you on where there's a real challenge will help us identify the additional policies that we need to really think about. And and we're trying to move it fast, but I have come to appreciate that policy moves slow.
Yeah, I think that's true, and we're attempting to write some papers and define some terms so that we at least can start to have some common language. Ben, I think if you don't mind, we'll try to slide your question that you just put in Slack into a subsequent opportunity, just because we're a little bit time limited. So I apologize. I do want to quickly go through the goals of day one today so that we are on track. So I'll roughly explain it as, we're trying to get calibrated. We want to catalog where we are. We want to identify the gaps and challenges. And then by the days in at day two, we want to make sure that we're prepared to go forward with some clean ideas on what needs to be done in the immediate next 12 months. At least that's the way I'm thinking about it. So next slide, please. So I just wanted to show this. You can't read the text on this. This is the text that was generated in preparation for the first meeting of NCPI, which happened to take place in Chapel Hill, which was focused on the brainstorming of potential activities. So we've narrowed things down over time so that we're a lot more focused now, and we've made considerable progress, which we're going to hear some about and talk more about. So next slide. So we have created 5 working groups that are moving forward on policy and development of software and additional tools and techniques. We have multiple use cases that we've used largely to drive this process. So I think the NCPI has been pretty well disciplined in staying on track on the things that we were trying to get solved. We'll have Brian explain a nice success story coming up shortly. So for example, BD Catalyst used funds from Susan's office and NHLBI to support the development of interoperable auth-C and auth-N methods, search capabilities, semantic harmonization, and cross-platform compute on KidFirst and Anvil. And we'll have more updates on additional driving use cases on day 2. And so if you go back and look, you can click on this link in the slides, and you will see the summaries of the working groups to date. They're concise and to the point, and yet extremely useful. And I'm hoping that these will serve to allow our NIH colleagues to understand that a lot of work has been done in these working groups, and it's been a very productive couple of years, actually. Next. So this is a slide I borrowed from Susan, and she broke it into these 6 categories, and I just wanted to explain how this fits within what we're going to be talking about today. So if you go to the next slide, this is how we've been tackling these issues. So we have working groups in these 5 areas, and we have the reports out from them, and we're going to go dive in and talk more about some of those specific topics. So we have been in many ways nicely aligned with Susan's office. So the meeting agenda, next slide please, is focused on getting to done. What do we need to do to get some things completely finished? So actionable key topics that we hope we're going to be able to drive across the finish line soon: RAS, PFB, FHIR, cloud costs, and search. Of these, I think we have a pretty good handle on many of them. Cloud cost, I think, is a very challenging area, but we've already made some progress. And then in general, we want to talk about other interoperability efforts that gather the activities that we need to continue to work on, and we need to be thinking about how to think about the future past the 12 months. So shifting to today and looking at how those topics fit, here's how we're going to address at least 4 of the boxes that Susan has put up. We certainly need to come back into the sustainability of the data infrastructure and enhancing the openness of the community, and so there needs to be more effort done in the 2 boxes on the right, but we're not focusing on those 2 topics for this particular workshop. So next slide. So here's kind of the goals. We need to move the needle forward on each of these topics, both understand where we are and identify the gaps. So I'm going to ask that as we break into smaller groups, we focus in a sincere way with making sure that we've communicated with each other our understanding of where we are and our understanding of where we need to be, and make sure that we write down the points that we generate in order to hold ourselves accountable. We also need to find out what the status of the use cases are and whether or not we need to start thinking about additional use cases. We certainly need to be looking for the gaps for these topics and where we might use use cases to address those gaps. And then, as was previously discussed briefly, we need to figure out what are both the development blockers and the policy blockers, and ask if there are ways that we can imagine unblocking them. And then identify for sure the key next pieces that we're going to help NIH reach its goals. Because as you heard Susan talk about all of these different efforts underway, many of these are very significant amounts of money that are being used to collect data. And if we collect the data and do not generate ideas, knowledge, and treatments for patients, we have lost an extraordinary opportunity. Let's not waste a pandemic, folks. Let's keep pushing forward and trying to make sure that we're doing things as quickly as we can to deliver benefit to our nation. Next slide. So Today's agenda is going to be focused on moving into a demo next by Brian to showcase the excellent work that has been done. I was very impressed to hear about this. And then we'll do an updates on key topics. We'll have a quick lunch break. Then we'll have a breakout during the lunch break. After people go and get a sandwich, we're going to break into groups. And then we'll come back and talk about some of the plans for day 2. We're going to try to collect up right before the day 2 planning, the discussion on gaps and decide on what the concrete next steps are. Next slide, please. Then we'll come back. We'll talk about a report out of what we learned in our breakouts. We'll talk about the GA4GA relationship and how we might be able to leverage that more. And we should also add additional groups that if we're aware of other folks that are developing standards that we need to be attuned to or involved in, we need to make sure that we service those. Again, a lunch break, and then we'll have NIH breakouts in the coordination, and have finally at 2 o'clock, we'll do a use case overview and take a look at where we are on the existing use cases. And then we'll come back and synthesize the goals and next steps for the next 6 months. So we have a pretty busy 2 days. So I'm hoping that everybody hangs in there and has fuel and sustenance sitting beside them so that we can stay focused on making progress. And I wanted to mention one other thing, and that is that we've started developing a glossary. It's not full yet, but it is starting to get fuller, get more filled. And the reason we did this is very simple. As I met under Bob's able leadership in the policy and governance group, I realized that different people were using the same words to talk about different things. So I have decided that we need to embark on some convergence on what we mean when we talk about, for example, data stewards. And in fact, data stewards I don't think is in that list yet, or maybe even should be, because there has been some controversy around what we mean by data stewards. I happen to be part of a data stewards group, so I want to understand who I am in that role. So, or if I shouldn't be calling myself a data steward. And I realize that different communities will have different standards, but at least when we talk about particularly policy, we need to be pretty precise about our language. And that's turned out to be a challenge that I did not appreciate in the past. And so transitioning now, and I don't know if we're on time or reasonably close.
We're just a few minutes behind right now, Stan.
Well, I apologize, and I hope I haven't eaten into your time too much.
Sure.
So with that, I'll turn it over to Brian and Jack and Robert.
Cool. I think I'm actually up first. So if we want to pop ahead just a little bit. Hi, everyone. So I'm going to talk over FHIR and search a little bit. And so we didn't quite get the end-to-end going, but I think we have some each of us have some really important things to talk about. Next slide, please. So some of you have seen this before, and I just set the stage a little bit for the FHIR working group and the work we've been doing. There's obviously a really big spectrum with a lot of different players involved in the data transmission process. And I think the genomics group community really has done a good job of setting some of those standards, and they're continuing to work and operate on that about how do we talk about the files, what's really important. And I think we've been really focusing from the NCPI standpoint on the clinical and phenotypic data especially, but also the research study data as well, sort of that study metadata about how to represent it. And we've got a lot of really good processes that exist out there, dbGaP for one, each of the platforms has their own way to do it. And so there's a lot of steps, next slide please, that we need to work on. And so one of the really important things, the very core principles of what makes NCPI work in these cloud platforms broadly, is that idea of setting up these services that really allow you to solve some of these problems, that the services are implemented in that API fashion very consistently across the platforms so that you can operate from that baseline. Important things like DIRS, where you can say, hey, I know I need to get this file. I know exactly how to do it. We've all agreed on what this looks like. And I think from that standpoint, FHIR is really set up, and the work we're doing is to be something just like that. How can we provide that guaranteed service layer about what to do? And so from that researcher standpoint, that's the questions, hey, what's the data on these participants? What phenotypes they have? What other measurements might they have? Or even asking questions from the search standpoint about what studies have diabetes data. Next slide, please. And so from that standpoint, each of these systems then may have their own method to providing these services. I put Anvil Kids First up here. dbGaP also is working really hard on providing those services. But that way, now that research user, just like we'd hope, can actually go through and perform search, maybe across FHIR, hitting all of these data sets, these platforms independently. Next slide, please. And so the same kind of thing, can we provide tools then that actually on top of the FHIR services allow you to do common tasks? So not that FHIR will solve all problems for all people, but actually really give you that foundation layer so that I can build a tool that will successfully work across everyone and solve that research use case. Next slide, please. And so, in that standpoint, there's situations where you will access FHIR. Maybe there's situations where you'll want to use another service that interacts with the FHIR on your behalf. I think I see Dave up there, of course, and the portal team, right? And that's a really important task. And I think there's a challenge. One of the challenges they run into is there isn't a common foundation about what that metadata about the studies might look like and how to source that. And so looking to help, can we use these standards to help solve that problem? Next slide, please. And so what we did here, this is a quick overview. Or actually, this is talking about study data. One of the things we've been working on, specifically since the last workshop, is representing study metadata. The DiGiovanna team has done a bunch of work in FHIR to do this. We're taking and iterating what they've done both in FHIR and on principles. And so looking to kind of modernize it in this FHIR infrastructure. And so this is the work that I'm showing now, a proposal that we're hoping to continue to iterate on with the FHIR working that was introduced recently, and we're kind of showing off here at the workshop. Next slide, please. And so we haven't had a chance to kind of get through everyone. I'm gonna scoop through this a little bit, but the idea is that there's important categories of things like what type of information is recorded, how is that organized, who is in the study, and what's the summary of this information. That's really critical. It's nothing shocking. dbGaP does a good job of this already. And so, how can we kind of lift some of those ideas up into a FHIR infrastructure that's more structured codings and links more completely across all the data in this service-oriented manner. Next slide, please. So there's 3 products we're going to go through today. There's an example about what that data dictionary and that whole scope might look like that Eric Torstensen on my team has pulled together. He's also got a tool there that he used to generate some data. And then we have this browser tool that I'll show in a second. Next slide, please. So the demo, so we have this published implementation guide for FHIR that we've created. And we actually have several studies loaded into FHIR servers that we're using here to back this. There's an Anvil internal test server that is actually loaded into Google Healthcare API, and that's just for internal testing. I think Eric and I may be the only people with access to it. There's also a Kids First development server that's been open to NCPI developers that's actually using a different platform for FHIR, both cloud platform as well as a different actual server implementation. And for this, Eric Torstensen developed and ran this research study summary tool that actually looks at the row level data that's been loaded into these servers and generates summaries that are suitable, a la dbGaP summaries. You can go look at those you can go look right now for these studies to actually see what information is there. How many people have these phenotypes? How many are cases and controls, and some of those other demographic information. I've then written a quick Shiny app to actually look at those summaries and generate some interactive content. And so once again, the objective here is going to be really to show off, to create that platform. And so I think nothing here is especially super cool or novel or crazy or wow, I can't believe you can do this. But at the same time, there's a lot of work building this foundation that actually can be consistent and well represented, that does cover these use cases. And I think it's really important and really helpful. And honestly, I think it is cool. And I'll get to some of that in a second. I guess I'll skip the live demo. I've got a few slides in there. It does work. I have it running. Next slide, please. So this might look familiar to people. I kind of riffed on one of the row level ones I worked on before. And what you see here, and these are 4 study summaries that Eric generated from hitting 2 different FHIR services. So once again, using that row level data to create summaries to talk about this. And so this is actually from the Kids First, the PCGC data set. And we can see just some demographic breakdowns that are available here. Next slide, please. And so there's the browsers, the counts, that kind of thing. And for this study, there's a single group that's available. And you can see here on the right, you've got a big old list of phenotypes. And so, this is nothing special. It's just a table. But at the same time, right, this is the kind of thing that could be really useful setting that foundation for search or platform. All of these phenotypes, right, I just have text here, but these are structured concepts with codes in the backend that are linked to. And so, if you wanted to do that semantic search, you can free text search for this. I can take the same concept, whatever the actual text was, and I can actually go look for it in other studies. Or I can build out the semantic search from the vocabulary standpoint and say, hey, I want to look for this term, arrhythmias in different vocabularies, whichever one it is. If it's in SNOMED or if it's in HPO, we're able to do that. And so this is a helpful breakdown. It's a pretty quick summary, simple searching across it. If you hit the next slide, please. So another example here, and this is a CMG Baylor Hopkins animal study that we have selected. And so once again, just another demographic breakdown, a little bit of helpful information about what to expect from the study. And if you hit the next slide, I think one of the helpful things that we're actually able to do also is, once again, dbGaP does this, but actually represent these different study groups. And so now within that group, I can look to say, well, the whole study, what type of information, what are the summaries here that are available? How many people with this scoliosis are there in this data set, right? So that's helpful, but you can also then pick another subgroup, right? These are the IRB, or the data access categories. And so you can select those. Next slide, please, to kind of browse through. And so once again, this is helpful. This is just the HMB MPU. Let's count of courts, but if I said, hey, I want to use this data, but I don't want to get an IRB, now I have a sense of what that information is. And so it's pretty straightforward. It was really handy to use. It was actually great. And so I think next slide, I think we have one more here. And this is just a really, really simple search, right? You can look through that, look through the table. And I think the other nice thing is I could have, if I had about one more hour, right, do another search where I actually look across all the studies and say, hey, who has, I think, an arrhythmias, right? I use that example. Show me all the consent groups and studies that have arrhythmia data. I can do that really easily. It's with structured text. I can use those concepts. I can use free text search. So there's nothing novel though. But the nice thing also is if I was to create a synthetic cohort across studies and to pull all that data into a single group, into my sort of research repository for the work I'm doing, I can use this exact same study tool to summarize the synthetic cohort that I created. And so we can actually, now I as an end user can actually leverage those same tools that we're using on the platform level. So once again, if Dave and co create those really cool interfaces that are actually driven potentially off of some of this format of the data, this consistent standardized data, well, now I can use those same tools. And I think it really improves the ability to really set that standardized layer. And so we did this using all standard data, right? All from FHIR, the same thing, different groups, different implementations. Me on Allison's team did some of the implementation. Eric on my team did some of it. We're able to build these nice summaries that anybody can use, and you can reuse them. And so I think that's where we're at right now. We're actually able to use some of that relevant data we generated to create these summaries. I'm really excited to continue to engage, but I need to let the next group go. So anyway, thanks. Happy to talk later.
Great. Awesome. Thanks, Robert. So Robert was showing, the ability to kind of search across systems. Jack and I are going to pick up and look at how, once you've identified the data of interest and have its metadata and associated data, how do you actually then access that in a compute platform and work with the data in that regard? So if you could go to the next slide, I'm just going to give kind of a little bit brief overview of the systems interoperation working group. Taking a step back here, I thought it was remarkable. Last night, I wanted to update my numbers here, and looking into Anvil, BDCat, and CRDC and Kids First last night, we now have about 11 petabytes of data available across these systems on the cloud. And that corresponds to basically doubling our data set in the last year and a half. So this is really remarkable. And I think, when it comes to actually accessing the data and doing compute, everyone's drunk the Kool-Aid here that we need to move from that traditional model of download the data, no one can download 11 petabytes anymore, to the model where we have cloud environments ready to go, bring the people into the environments. What Systems Interop was really interested in here is how can we make that process really nice for users, but really nice for researchers, and make that process something that as a user comes into the cloud environments, they can access data across these systems. So really being able to access all 11 petabytes. So next slide. So that's what systems interop has really been focused on, complementing the FHIR working group that Robert was just talking about. Systems interop is looking at how do we improve the sort of data access and data compute capabilities and interoperability amongst the platforms. Next slide. And we've really done that by focusing on researcher use cases. These are really, really interesting researcher use cases that have been brought to us by the community, by real researchers. They're in various states. Some of them have finished already. Some of them are in progress. As of right now, we have 11 researcher use cases really driving the work for data access and for compute. Next slide. If we go back in time, though, and look at, I can't believe it's been 2 years. It's 2 years now since we started this effort. But if we look back at where system interop started 2 years ago, one of the things that we noticed is, yes, there's this huge transition to the cloud. Yes, we're building these cloud platforms. Yes, we're, at that point, we had about 5 petabytes of data. But what we noticed is the platforms themselves were becoming siloed in the sense that you would work with one data set, you'd explore it in one portal, you take it to one compute environment. And we really want to break down those barriers, break down those potential silos, eliminate those silos, and allow people to work across systems. So if you can go to the next slide. Okay, there we go. Great. And so our vision for interoperability within systems interop has been pretty consistent over the last 1.5 to 2 years. And that is, we want users to be able to be identified through, obviously, RAS now. That's been a great benefit to many groups and systems. So we want a user to be identified, be able to be authenticated and authorized, to be able to explore data through things like FHIR or the portals, the data browsing portals that are accessible, to be able to create a synthetic cohort of interest, do searches of interest, and hand off that search or synthetic cohort to a workspace environment that they want to work in, a cloud-based analysis environment that they want to work in. And that cloud-based analysis environment, it should be able to access the data from not just a particular project, but all the projects. So we wanted, in this example, I want to be able to find Biodata Catalyst and Anvil data, take those references into the Anvil workspace and be able to compute on them. So next slide. So that's been the vision, for the last 2 years, and we've chipped away and we've made progress. The 3 areas that we've really focused on to complement the other working groups that are happening as well is this search result handoff process. We've explored PFB. We've also explored a PFB FHIR bridge that we talked about during the last meeting. As far as data access goes, we've really doubled down on GA4 DIRS, and that's been a huge benefit. And we've seen that deployed across all of these systems. And then as far as auth goes, really the rise of the RAS system and having that become available using GA4 GH passports has been a huge benefit as well. So those are 3 sort of standards or areas that we focused on in systems interop. Okay, so next slide. So what have we done? It's been a busy 2 years, despite the interruption of a pandemic and not getting to actually hang out with you all in person today. We've been very productive. In 2020, we worked on things like MOUs, ISAs, getting systems to talk to each other and be allowed to do that. We've worked on PFB. University of Chicago created the PFB format and demonstrated its utility to hand off search results from BDCAT and Anvil portals to workspaces. We've seen another University of Chicago achievement here is the deployment of DIRS across Anvil, BDCAT, Kids First, and CRDC data repositories, and a lot of progress on use cases, gathering them and seeing progress being made. In 2021, a lot of progress was made with rolling out RAS for authentication for GA4GH standards evolving. More systems supporting PFB handoff, for example, PDC is working on that right now. And we showed a bridge between the FHIR work that Robert was describing and how we import sort of synthetic cohorts using a FHIR to PFB bridge prototype. More workspaces have added support for more DIRS servers. And I'll come back to this. This is kind of the punchline at the end of the presentation. RAS passports for authorization, that design work has happened, and we're going to talk about that quite a bit in the RAS session today. And then researcher use cases have continued to evolve. So with this, I'm going to hand it over to Jack on the next slide to talk a little bit about some examples of the use cases and the successes that we've had.
Yeah, thanks so much, Brian. Can everyone hear me?
Yep.
Awesome, thanks. So yeah, I wanted to review a couple of the use cases that we've had over the, earlier in the year, and then we'll hand it back to Brian to get into the more recent use cases. The first one here was Wilson Macaro, who was looking at the retrotransposon line 1 activity in tumors and healthy tissue. And in order to do that, he and his group needed to combine data from TCGA, from the Proteomics Data Commons, and from GText. And that wrapped up in the spring of 2020, that was demonstrated. The next one, calling back to Robert's example with the first FHIR tool, was led by Deanne Taylor, which was looking at the pediatric cardiac, the PCGC bench to bassinet consortium, where part of that data was collected by Kids First and part by TopMed. So it put researchers in an interesting situation of, well, how do I don't really care who governs it or who collected it, but I just want to do that analysis. So that was a really neat use case that was driven towards the fall of 2020 into the spring of 2021, being able to realign that and joint call all of that data together. And that was done on Cavatica, the first one on the CGC. What's really exciting is both of those efforts have led to one or more publications that are in process or under review. So it's exciting to see the science that was enabled. Looking at the proof of concept here at the bottom with this goofy diagram, in April 2021, we presented a proof of concept that's bringing together, that brought together the Kids First, TCGA, GText, and TopMed data all in Cavatica. This was all done leveraging ERA Commons IDs and DIRS. But if you do a click here, one click, please. Yes. So some of the data had to be copied there due to misalignment with how RAS M3 was proceeding. So in this case, the GText data was brought over, and we used a different auth system. So if you go to the next slide, please. So while that proof of concept was fast and it fit the vision that Brian put in that first slide of we're going to take data from any portal and put it in any workspace, the flow was a little clunky. So 12 minutes, including all the authentication, parsing, creating manifests, but we had to follow this timeline on the top where we're starting in Anvil, jumping to BDC, jumping down to Kids First, we're back to Anvil, right? So the UX, there's room to improve. So if you click through, our partners at the University of Chicago have actually mocked up here buttons. So now instead of downloading the PFB, now there's an export button where you could specify whether you want that to go to Biodata Catalyst, CGC, Cavatica. You can also see Terra right there or other workspaces. So really making it easier for the user so they don't have to do that download and upload flow. If you go to the next slide, please, and click on the video, I shared it, it should be able to go. This is a mock of starting from Biodata Catalyst, hitting that button, and now you're going into the Cancer Genomics Cloud, walking through the dialog here of how to import. There's an authentication error, so you follow an ODIC flow, and now you're authenticated using those RAS credentials, and that manifest starts to import into the project or workspace. And over time, once it's parsed, you can see here now you have the file and it has the associated metadata. So that's a mock of something that we're developing right now and expect to go into production soon. Thanks, I'll hand it back to Brian here.
Great, thanks. If you could just move to the next slide. Yes. All right, so thanks, Jack. Looking at another use case success story, this was one that we talked about in the last meeting and various other meetings as well. Use case 7, this is Tim Majorian's use case looking at congenital heart disease. What's interesting here is much like the previous use cases, there were elements of this that were highly optimized. In this case, Tim was able to go to the Anvil portal and BDCat portal and do that clean handoff that Jack and I described previously and access data in place in Terra. But there were other more difficult parts of this process use case. In particular, Tim wanted to work with Kids First data And so he was able to write code that was allowing him to pull that data into the platform and download it. But unfortunately, the data needed to be downloaded into his bucket, and then he could use it. So if you can click on this, we'll have a little, thank you, a little animation. So this was great because we saw Tim able to work across data sets and actually write a paper. So he was able to write a paper off of this by combining these data sets from Kids First, Biodata Catalyst, and Anvil. So that's fantastic. The other piece of feedback we got from Tim was it was very time efficient for him to use the export to workspace, what Jack just showed, that ability to click a button and send a synthetic cohort to a working environment. That saved Tim countless hours, as did Anvil and Biodata Catalyst being able to be used directly in the Terra platform through that DIRS standard. On the Kids First side, being in the situation of downloading that data to his bucket before computing, that added many hours to this effort. And obviously that doesn't scale if you're talking about petabyte scale. So if we can move on to the next one, let me fast forward in time to a more recent use case, which is leveraging some improvements to the way that DIRS is being used. The punchline here is that over the last week, Terra has actually added the ability to directly work with DIRS from Kids First. And so in this example, I did some prototyping work with Melissa Wilson's use case 11. This is our most recent use case that we've written up. And Melissa's going to talk about it a little bit more, I think, later on today or day two. Interestingly, this is one of the original use cases that was proposed in the very first meeting. So it's very cool to see this come full circle here. And in this particular use case, what we did is we wanted to do some coverage analysis across CRAM files from Kids First, Biodata Catalyst, Anvil, and CRDC. This is the stepping stone into the first sort of QC step of Melissa Wilson's sex as a biological variable analysis use case. And so I looked for data on each of the 4 platforms using their portals. I used a combination of PFB and manifest handoff. And then I wrote a tool in WDL on Terra that would allow me to look at the coverage across the X and Y chromosome in these CRAM files. So if you can click on the button, a little animation will play. Okay, it's not much of an animation, but the punchline here is because the Terra platform has now added support for Kids First DIRS server, I was able to do this without staging any data, without copying any data. I didn't have to worry about all that work that Tim did to move data around to his location of compute. I just was able to hand the DIRS URIs to my workspace in Terra, and Terra was able to actually access data in Kids First, along with Anvil, Biodata Catalyst, and CRDC. And so that was very, very exciting. If you click on the next slide, I know we're a little bit over, but I do know that the RAS section, I think, will take a little less time. So maybe we can go ahead and play this. I'll show you what this looks like from a researcher perspective. So in this case, I'm trying to find data across these 4 platforms. I'm looking in Anvil here. I'm selecting data. Apologies for the resolution, it's not great, but I'm selecting data and using that PFB export. So again, this is very easy for an end user to be able to export to a workspace without having to do any manual intervention. Same goes for Biodata Catalyst. I'm looking for data in the portal. I'm creating my synthetic cohort, and I'm using the export to Terra button to send that PFB over to the Terra environment and create my workspace without having to do a bunch of sort of manual intervention. Along the way, DIRS URIs pointing to big data files are being transferred. I can take a similar approach on the GDC portal. I can select the data I'm interested in, but this time I'm using a manifest. And this is something that we need to work on. This is me writing a Python code that translates that manifest into something that Terra understands with DIRS URIs. I'm adding those DIRS URIs into it and doing a similar process for Kids First. I'm translating the manifest into a manifest that includes the DIRS URIs that the Terra workspace understands and can automate the access of, and now uploading that. So at this point, I have a really nice workspace that's been curated. I've done cleanup on it, and I have Anvil, Kids First, CRDC, and Biodata Catalyst data. And DIRS URIs are understood here in this platform, so it understands how to resolve them and access data. Now I'm putting together my coverage analysis workflow, parameterizing it, and selecting a bunch of CRAM files, in this case from Kids First, to go ahead and launch that analysis. Again, data isn't being copied around. It's not being staged in my bucket. It's being accessed on demand through the DIRS URIs across these 4 platforms. So with that, Sarah, or whoever's driving, if you could click to the next slide. Are we caught in the loop of? Okay, great. So this is the next slide. So I know we're a little over. I just want to kind of highlight, I think, what are our priorities in systems interop here? What are we hoping to focus on in 2022 going forward? I think it's fairly simple. At a high level, we want to finish ARAS milestone 3. We're going to talk about that in a few minutes. Many of the folks in the call are very much involved in this. We want to move, if you can click on the slide, we want to move from a user having to link many, many accounts to having a single, very nice RAS login that is a single place where they can link their identity. The next slide. The other thing that we want to do for the future is we want to connect more portals. We heard from Tim, we heard from other researchers that this ability to find data in a portal and click a button and have that interoperability happen where PFB or FHIR or some other mechanism is used to transfer DIRS URIs to a workspace that I can then work with the data. That automation is really appreciated by researchers. So if you can click here on the slide, we want to move from that sort of model of having to modify and script and change the data in order to get it into your workspace to one where we can add many different portals in the future with a send to analysis, send to workspace button. And we also want to make it easy to add additional DIRS servers in the future. We've got 4 DIRS servers, a 5th one coming online. We want to see a whole ecosystem of data resources out there. The next slide, please. And then finally, now is really a great time for us to take a breath. It's the 2-year anniversary of this group, which is amazing. But I really want to tell users what they can do. And I think this is something that we need to work more with the outreach team. As of last week, Terra is in the situation where it supports DIRS on all 4 of these platforms, making 11 petabytes of data accessible. 7 Bridges is in a similar boat as well. We want users to know that today they can do work. This is not a demo. This is not demoware. What I showed with Melissa Wilson's use case is what any researcher that's authorized through dbGaP can do. So I really want to make sure that we loop in the user community and get people using the capabilities that we have built into the system and leverage the progress we've made over the last 2 years. Next slide, please. I think the last one is just to say thank you. I apologize again for running over here, but I can't tell you how many people have been involved in this. I can't tell you how much I appreciate everyone's work to make this experience better and more powerful for researchers. And I'm so excited to see the progress we've made. And I can't wait to see what we do over the next year. So thank you very much, everyone.
So I believe Becky's up next, if that's the case, but I just want to make one quick comment. I think this is amazing progress. What you all have been able to do, it may be clunky, I understand that, but this is would not have been possible 2 years ago or a year ago to be able to use all of these systems in some continuous fashion to be able to solve a problem. That is a major accomplishment. Yeah, we've got a lot of work to do to make it easy and straightforward, but that's impressive. Thank you all.
Okay, well, thanks for that, Stan, and thanks for reflecting on that. I think I'm seeing a lot of very positive things in the chat, so I think people are hopefully, as I am, impressed with what's been done over the last several months and last 2 years, really. So what I want to do is just tee up our next session. It's going to run from 25. We're running slightly behind till just after 1. We'll then have a lunch break. So we're going to do updates on these key topics. This will be led by some folks who've been working with various platforms to gather and pull together these updates. These same folks, Brian, Robert, and Bob, will also lead the breakouts that follow lunch and will enable and kind of facilitate the report back. So thank you to you 3. And with that, we can go ahead, I think, and transition to PFB, which Bob is going to give an overview and progress update on?
Thank you. And I just want to echo all the teams that worked so hard on implementing the different technologies that led to that demo. Well, that led to the technology that was shown in the demo. I just want to step back for a minute, and these are very short. I'm going to summarize what some of the teams have done. Then there's time for a few questions, as I understand it, and if not, I'm sure the organizers will correct me. Then we'll go on to the next topic. So the portable format for biomedical data is a self-contained, self-describing, application-independent bulk format for structured data, such as clinical or phenotype data. It's based on AVRO. The early work in trying to create formats like this looked at both protocol buffers and AVRO. Both are machine-readable formats for bulk data with a schema. The main difference is AVRO is self-contained. The data dictionary is there. The data model or schema is there along with the data. So if you come back to it in 2 years or 3 years or 6 months, you have what you need to read it into an application on a different platform or in a different system. Protocol Buff is Google's version. It has a lot of advantages, but you need to have to locate a schema file. And I haven't learned much in my life, but over time, files get lost. And if you need several files, they're not likely to be together again. And also, these days with persistent IDs and associated metadata making data fair, having a single object with a persistent opaque identifier and associated metadata, you can come back to bulk data. And so that's the goal. I want to emphasize that PFB does not specify a particular data model. It's up to the working group or the organization or the governance structure that's working with the data to do that. We used it internally within Gen 3, and so we used the Gen 3 data model. It's a graph model. It's more common to use a relational model or FHIR model. Importantly, as I understand it, I'm going to show it in the next slide or two. Kids First has a version of PFB that connects to FHIR, so it's in the FHIR data model. What we've done for interop is have sometimes we call it a light. It's a very simple PFB that's sometimes used that is just core data, sort of, so you have a manifest. On the other hand, when you go to clinical data needs a schema, and so presumably an NCPI will be working out minimal schemas for enhanced interoperability. We've already seen interoperability. This would be enhanced interoperability. Another way of thinking of PFB is it's one of the alternatives for bulk FHIR format. So that's my quick introduction. It's important for interoperability because we have good interoperability these days for the BAM and CRAM and imaging files. We have less good interoperability when we want to come back to bulk clinical data or phenotype data or other structured data associated with an analysis, a reproducible analysis. Once you have a bulk format, you can assign a persistent ID and metadata. So with that as a general introduction, can we have the next slide? We can look at what's been done. Initially, we used PFB as an interchange format between the management capability of Gen 3 and the analysis tools provided by Terra, Seven Bridges, ISB, and other platforms, that will be increasingly used like Galaxy and notebooks. That was when you created a virtual cohort. What we're doing now is extending PFB for bulk for studies so that they can be stored and accessed, and you don't necessarily have to use create a virtual cohort. And we're also adding PFP exports from Gen 3 infrastructure to an increasing number of workspaces to make it easier. So Seven Bridges is developing interoperability to send PFP. Right now they have it for Biodata Catalyst and Anvil, but they'll be using it for some of their other platforms, as I understand this. Next slide. Terra currently supports PFP import, and this is a light PFP. You know, it may be, as I mentioned, in the future, we may want to add more rich clinical data, especially to study level versus virtually co-created cohorts. And they're going to support PFP for other portals, such as the proteomic data comments. I already mentioned Kids First has a open source generic library for converting FHIR resources into Avro and vice versa. And again, the important thing here with PFP is it's an Avro format with a data model that's self-describing and can be assigned FHIR attributes. It's up to working groups like this to figure out, as they've done for the interoperability that Brian and Jack and others showed, and Robert, what exactly is in that schema and how it's populated. Next slide. NCPI pioneered another portable genomic format over a decade ago with VDB that they use for SRA. Importantly, it's column-based, which is important for scientific computation, and they're going to provide APIs for VDB. There's NCPI outreach is shown there. So I try to keep this short. I think that's the last slide. And Stan or Becky, do I understand this correctly? Well, do we have discussion on PFP, or we to go to FHIR, or are both those wrong and we should be doing something else?
No, thanks for that, Bob. I think we can take one question, maybe two, and then I think we have the breakout room for more extensive discussion, and we'll throw it to Robert to discuss FHIR after that.
And I do want to say I'm teaching face-to-face today, and so I won't be in the first breakout room for PFB, but Robert and Alex Vanto from Robert Carroll will be there for FHIR, and Alex Vanto from our team will be there. And I apologize, but I'm teaching during that.
Well, that sounds like progress, Bob, teaching in person. So we totally understand, and we'll make do in your absence. Does anybody have a question on PFB? Either raise your hand or throw it in the chat, and I'm monitoring both. All right, Ben has a question. Ben has such good questions, so it's going to be a good one.
Yeah, that's pretty good. PFB is not designed currently well, first of all, I may not know enough. If VDB is for genomic data, column-based for genomic data, that's not the immediate use case for PFB, which is for structured data, such as data in a database related to clinical or phenotype data, biospecimen data, et cetera.
VDB,
it doesn't mean
VDB
it doesn't make sense. What's that?
VDB is a schema-driven columnar store that can represent any data of any sort.
Okay, thank you. Who responded?
That was Kurt Rodemer. Do you want to?
Thank you, Kurt. Yeah, so it may or may not make sense. I don't have a good feeling. PFP is not column-based, it's just Avro. Kurt, why don't you respond? I was just responding to the use of PFB in this consortium NCPI for interoperability of bulk clinical and phenotype data, but obviously it could be used more generally. Any thoughts, Kurt?
I will try to answer the question in the chat, but yes, they're both general purpose. SRA has made use of VDB for the specific use of massive genomic data, but it can be used for other, and in fact, NCPI does use it internally for other purposes.
Okay. Yeah, I mean, I think these kind of first of all, there's the issue of vertical column-based versus non-column-based, which is absolutely essential, especially for scientific computation. Then there's the second issue that Avro protocol buff VDB addressed, that if you're in the business of interoperating systems, you need some efficient mechanism that's not as expensive as XML or JSON, and that's where presumably VDB, PFB, and Avro come up. I think we should move on now.
I think, yeah, Ben, if you want to type in the chat your question, maybe Bob can have a look there and answer, and that'll enable us, since we're a little over time, I do want to hand it to Robert Carroll to discuss the progress we've made on FHIR.
Yeah, thanks everyone. And so I thought it was interesting, Bob started off with a little bit about what is PFB, and just as a reminder, I wish I had Allison's good slide about this. The FHIR use cases that we're really talking about actually go from data ingestion and data representation all the way through to data access, and then even to potentially data used by researchers. And so we've got a lot of exciting use cases, and you'll see that represented in the work that the teams have been doing. So I'll start off on the Anvil side. We've done a couple of things. We've actually gone ahead and done a proof of concept Anvil FHIR server setup. There's some really internal only Anvil dev team access for that, simply because of access control reasons. There's also been some work across the Anvil team about looking at potential integration with Terra and how to make some of those services available through Terra for the Anvil. We've also implemented the transformation of the NCPI model for some of the data we have, specifically the CMG data that we demonstrated earlier. I showed off that implementation of the study and summary level model, and there's some more information in some of these links. There's also been a RIDCap FHIR module that's been updated to export resources, sort of at the minimum requirements for what we're doing here. For instance, that would support the CMG data use case. So if you're looking to capture data, and this is once again on that data ingest side, how do I help better get data into the Anvil? There's some solutions that we're working up there as well. The gaps to next steps in that case, right? Wider release. We're going to have to, the Terra team is continuing to work with a partner on that. And I'm really excited for the work that they're doing. Fortunately, Google has done they FedRamped the healthcare API. So that's a really valuable product for all of us. And so I'm really excited. On the Biodata Catalyst side, they've been doing some data ingest as well on the FHIR aspects, especially with picture. Working on some FHIR server deployments for Google and FHIR, and they're doing some conversion of the HL7v2 and CCDA documents, which are some standards pretty common in healthcare and data exchange as well, and looking at some FHIR and PFB export. And they're going to continue to look at loading data into picture, as well as some of the more real test data and use cases, and looking at appropriate data is accessible via FHIR for the BDC, which I think is exciting. Some more slides, and a lot of teams, maybe next slide, please. A lot of the teams are really involved in actually making some of these services and contributing to the NCPI pieces. Can we get the next slide? Sorry. Oh, there we go. Great. And so the Kids First team has done a bunch of work as well. So were major contributors to that FHIR implementation guide, as well as loading a number of projects that have been released in dbGaP in the Kids First Data Resource Center. Oops, sorry, we're still on slide 2. Let me pull this up.
It's on slide 2 now. If you're not
cool.
seeing it,
slide 3. So maybe this is all on me, on my end. There we go. I'm finally caught up to everyone. Yeah, so they've loaded a number of projects, and we showed the example earlier of the PCGC data only that we demonstrated. But there's a number of data sets that are released and available. I think hopefully this week, I think they're going to actually have some actual live production FHIR services available for use by researchers. They're working on doing some of the dbGaP research subject and study model. that I think we're all hoping to collaborate on moving forward. They've got a genomics module up and coming, specifically for linking sequencing data and methods to the samples, which is really exciting because I think there's been challenges with representing that metadata in a standard compliant manner. Then the auth-in and auth-z, how to do that with OAuth2, and which is also exciting. I was able to do some with Google, but there's also access control concerns around that too. They're working with Kurt R to do some RAS FHIR integration, the pedigree side, how to represent that appropriately, and I think that's some cross collaboration with what's happening in G4GH, trying to make sure that we have a consistent representation there, and then some more questions about how to best represent this data on the phenotype side as well. And then also the next slide with dbGaP, and so I'm going to go ahead and look. Let's see. dbGaP team has been working hard. I know they had a big release here in September, and they've made a bunch of study level metadata available. They've also made an initial set of variable level data available as well, and they're working with the prototype of RAS access. So, and they're hoping to complete that in Q1 of fiscal year 22. So that's really exciting as well. And so that's actually going to allow controlled access groups, which is really valuable. I think one of the big gaps to address. So they're continuing to scale up the servers and to test loading. They have a ton of data, and so making that actually available in a service architecture is a lot of work. And so they'll continue to develop that and improve the performance. They're going to continue to work with integration on RAS, which I think will be an interesting piece for the FHIR and RAS integration. And they're working with the LHC at NLM, who's also been coming and joining the FHIR working groups to actually figure out the best way to model and standardize the data that's found in dbGaP, because a lot of it is sort of the Wild West when it comes to clinical and phenotypic data. And then they're going to keep working with some of their data capture teams there. And the ample data set catalog. And so I hope we can continue to collaborate on the development of these research study models as well. Cool. And then I think there's one more slide with NCPI outreach team who's been linking some of the documentation that's available, and I'm hoping to continue to look forward to them. And I guess one thing I totally forgot to say, we are also working towards a codeathon that's up and coming, that is funded through the ODSS that Alice and I are leading. And so that's going to be really exciting, where we're going to hit get some folks boots on the ground with some use cases. So anyway. It's a lot of exciting work across that whole spectrum of data ingest to data transfer and data availability.
Thanks for that, Robert. I know we're running over, so I'm just going to ask one question, or others put your question in the chat, and Robert, hopefully you can monitor that and answer folks there. All right. With that, we're going to transition to Brian, who's standing between us and lunch, Brian. So no pressure.
No pressure indeed.
All right.
Okay, so yeah, I'm going to do a RAS update. I want to do this a little differently. As I'm going through the different tables, I do want to open it up to the teams to actually contribute to that and jump in. So please feel free to interrupt. I'll do kind of a just general overview of where we are with RAS across these systems, across NCPI, and then kind of dive in and invite people into those table updates. So, just as a reminder, what are we doing here? Well, at the end of the day, RAS is a GA4GH passport system, and we want to be able to be in this situation where compute environments can get these passports for a researcher that includes visas that describe all the data sets that user has access to, and then use those passports on the behalf of the users to access a bunch of data. And of course, with NCPI, we're talking about BDCAD, Anvil, Kids First, CRDC, and also the NCPI DIRS server that's in the works as well. So next slide. So that at the high level is what we're trying to do here. And what's awesome about this is it's a standards-driven and modern authentication and authorization system. So it's really, really awesome to have RAS as a resource here. What we've done collectively you know, it's difficult to get everyone to kind of switch to the same auth system, especially as things like passports and DIRS are still evolving as standards. So it's taken a lot of coordination. It's taken a lot of time, effort, and energy by a lot of folks that are on this call today. And so we worked together on putting together a series of design documents. The latest one is linked here from the slides, are what we're calling our milestone 3 design document. And the milestones that I'm talking about here, you know, we had a 3 milestone plan. The first one was login with RAS. So using an OIDC flow and being able to do the standard sort of who are you login with RAS. That's now in production. So if you go into these systems and you're a researcher, you can actually use RAS to do your login with your ERA Commons identity. Milestone 2 ended up being skipped and rolled into milestone 3, where milestone 3 is the flow that I just described, where RAS passports with embedded visas can be used directly, can be obtained directly by, you know, workspace environments, and then used directly with DIRS servers to access data. And so we went through a very extended design process and collaboration across a lot of different groups, University of Chicago, the NIH groups. But ultimately in quarter 2 and quarter 3, we ended up collaborating on this design, collaborating on our milestone 3 design. And now we're on an implementation timeline. So next slide. Okay, so summary of milestone 3 here. Well, this was work by University of Chicago, the RAS team, Kids First, CRDC, Anvil, Biodata Catalyst. This proposal, or this milestone 3 design, you know, proposed that the current system that we use today to retrieve Gen 3 opaque tokens and use them exist in parallel with a new approach that uses passports. If you can go to the next slide. Okay, in this new passports approach, our design was such that systems can interact with RAS directly. They can receive the RAS GA4GH passport that includes visas embedded that describe what that user has access to. And they can use that directly with a data server like DIRS to access data resources. So in our original design, the idea was that clients would get the RAS passport and also be able to repackage that passport with their own visas or visas from other brokers. That was scratched, actually. That was scratched out of the plan. So the plan right now is that RAS passports can be used, obtained directly from RAS and used unmodified and sent to a DIRS server to retrieve things like a signed URL for data access. But that passport is being used in its intact form. Overall, though, regardless of whether we support signing and repackaging or just use the RAS passport in its entirety, this still significantly improves the user experience across the various NIH IC stacks, the ones that are involved in NCPI, for example, because it means that these systems can do one login event versus the screenshot I showed you earlier, where you have multiple account linking events out to multiple systems. And ultimately, by making this a lot easier, we're going to open up data sets across systems like Anvil, BDCat, CRDC, Kids First, NCPI, and just improving the user experience of being able to interoperate with this common, you know, for lack of a better term, passport that allows them to access data that they're authorized to see. So that's the sort of overview of the passport approach that's outlined in our milestone 3 work. If you could go to the next slide. So we learned a lot along the way. We learned that the RAS passport needs to be unmodified. So we're working with the RAS passport that has not been repackaged. DIRS 1.2 was just released a couple of weeks ago, or actually last week, with the GA4GH meeting. And it now supports the ability to send multiple passports in their entirety to a DIRS endpoint to retrieve a file. And this makes it compatible with this approach where RAS passports can be sent unmodified, along with potentially other platform passports as well. So next slide. Another thing that we learned after a lot of conversations with security folks from various teams, all teams have indicated in our design document that mutual TLS authentication for client verification is required. And so this will allow passports to be handed from a trusted client to a trusted DIRS server and have that client and DIRS server relationship to be made clear effectively, to have that relationship be trusted, because the DIRS server can both look at the passport and see if that user is authorized, but then also use mutual TLS in order to understand if that client and the system it represents should be trusted as well. Next slide. Okay, and then another thing that we did along the way is the teams recently agreed to a timeline and that in the milestone 3 plan. And so this is huge, getting everyone, this is probably honestly one of the biggest challenges we have with this huge collaboration of NCPI, is getting people to align various projects timelines, which were never intended to be aligned in the first place. So being able to get everyone to agree to how we implement milestone 3, but then also what is the timeline for that? And we've had sign off from the platform architects, we've had sign off from the POs from NIH, we've had sign off from security teams to this timeline, with the bulk of the implementation happening between now and the end of Q1 2022. So next slide. The Gen 3 University of Chicago team has also put together a detailed technical plan and shared that with the RAS team as well. The RAS team has stated that they're ready and willing to provide support on the clearinghouse design and move forward with the process. So it's excellent to see the technical details from Chicago shared, feedback given by the RAS team, and a desire to move forward with helping in the clearinghouse design, which evaluates the passport. Okay, so next slide. All right, so that was a long-winded introduction to the state of RAS. I just want to kind of quickly go through the tables again. I want to have folks from each of the teams feel free to jump in here. On the Gen 3 side, we've seen full implementation of RAS for Auth-N, as I stated earlier. And really, Gen 3 has been a wonderful partner in terms of the discussions about milestone 3 and the sign-off from SIA with Chicago and the CBIT security team. So continuing to move the security ball down the field. In terms of gaps and next steps, I think we have reached consensus on milestone 3. We've had sign-off on that, and so that's been great to see. But of course, there's a lot of implementation tasks left for Gen 3. I would say that's probably the biggest challenge for the group, since they are the interpreter of the RAS passports coming to their DIRS servers. On the 7 Bridges side, 7 Bridges is working to get RAS passports directly from RAS, as are a lot of other systems as well. They're working on the full implementation of RAS for Auth-N, for authorization. And ISAs have been signed with all the relevant systems, and they have given their approval for milestone 3 plan. So that's been great. In terms of gaps and next steps, 7 Bridges, like other platforms, workspace environments that are going to be using the RAS passport to access resources for a user, are dependent on the upstream implementation of RAS passports and things like the DIRS server, and looking at SOPs for support of end users is another area of work. If you could go to the next slide. On the Terra side, a lot of work has happened with the external credentials manager. And so this is the system to be able to interact with RAS version 1.1 passport specification and to retrieve that. So much like the 7 Bridges group has been working on the retrieval of RAS passports, the ECM is doing that on the Terra side as well. Much like 7 Bridges, Terra is planning and working on the development work for RAS passport support for the Gen 3 DIRS servers, but needing those DIRS servers, at least in the staging or dev environment, to be able to test this implementation. Coming down to the FHIR team, FHIR is currently using the Gen 3 based opaque token authentication and authorization approach, but looking for, in terms of next steps, looking at leveraging RAS passports for authorization once that's available. So again, a common theme of wanting to have a test environment where that's available. Next slide. I think this might be the last slide until lunch. So in terms of the NCPI side, NCPI has released RAS Clearinghouse version 1. And so this is the service that processes RAS passport tokens. They've also been very active in the GA4GH DIRS side and looking at both looking at the changes and also suggesting the changes for DIRS 1.2 to support that posting of RAS passports. In terms of gaps and next steps, looking to give feedback and bring things in line with the officially released DIRS 1.2 that happened literally just last week, piloting passport version 1.2, so the evolution of passports in the support of FHIR, which Robert mentioned earlier, and then provide externally accessible pre-release support for developers. Again, this is an underscored thing that I want to focus on. Giving developers access to testing environments is really, really important for us as we roll out this milestone 3 RAS support and other activities as well. And then finally, outreach activities. The outreach group has been linking to documentation on RAS, which they have excellent documentation on their website. And then the next step there is to continue to keep the RAS documentation up to date as things change. I think we may be at the end.
All right. Well, thanks for that, Brian. We just did a whirlwind tour through 3 very major efforts. So I know we touched on them briefly, but hopefully it gave everybody a sense of where we've been and where we're going on those 3 efforts. I do just want to note also, Brian, thank you for keeping us on time. We're right at 1, so we're going to break for lunch. However, there is a RAS breakout at 1:15, and I'm going to hand it briefly over to Patrick Patton, who's going to discuss some of the logistics of our breakouts.
Thanks, Becky. Yes, great. So as Becky mentioned, we will be having a RAS breakout starting at 1:15. So this will be a separate breakout room that will open at that time. If you have the most current version of Zoom, or I think just one of the more recent ones, you should be able to move yourself. If not, please reach out to one of the hosts that you can see on the participant list, and we will be able to move you to that breakout. So that will run from 1:15 to 1:45. So hopefully the next 15 minutes, you can grab some lunch and then hop over to that. We will be having other breakouts later in the day, but for this breakout, please do plan on coming back at 1:45. And that will be, yes, that'll be when lunch breaks. So everyone should plan on being back here at 1:45.
All right. Thank you so much.
I do want to ask before we break if there are any questions about getting into the breakout, because this is maybe a little different from how we do it sometimes. Does anyone have any questions? Great. So enjoy your lunch.
Everybody stay here in this Zoom.
If you want to, well, you can go, but if you this will be the Zoom where the RAS breakout is. We'll open up the breakout room in 15 minutes in this same Zoom. You should be able to move yourself, or we can help.